here you gotta know obviously very exactly what you're doing. There's no guardrails, nothing. You're on your own here to know what you're doing. But since we're providing all this documentation, this is about the best help that we can give you. I mentioned before the trace feature, the trace analysis. This is a feature of the Atom processor. It has an on-chip ring buffer that, if it is enabled, it records branch points where the instruction is branching off. They get stored into this ring buffer, and you can analyze them later. For example, if your application crashes, it probably has not executed what you expected it to do. Now, how do you find out the path that was actually executed before the crash? You were expecting it to single step, and you have all the source and everything. You even look at the assembler, but it just doesn't do what it was expected to do. Now, if you switch on the trace, it will record these branches that were actually taken, and after the program stopped, the crash or whatever, you can read out the trace buffer, and then you see actually from the trace points the actual execution path in between is linear. Otherwise, there would have been another branch, right? So it can reconstruct from the branches a couple of steps backward from where it crashed, and you can actually see what happened. So this is supported on chip by the hardware on Atom. Similarly, you can do this with the application debugger. Then it's just get mapped into memory, and you can look that up out of a portion in memory. So this is also indispensable, I think, say, for system development if you run into problems with your target. Okay, in short, I think we have a number of good features that help speed up development in all of those tools. As I said, I'm not going into those features that are common to the, let's say, the classic tools, the Parallel Studio, the compiler, the IPP. This is well known, and this is no different from what we need on the embedded side. Now, where are we going? What do we think is of interest, is relevant for future? Right now, we're trying to optimize applications. So what does that mean? Optimizing today means typically you have an application sitting on, let's say this is a power consumption. Now, if the application is idle, it consumes a certain number of power. Then it gets active, and after a while, if it's executed its task, it gets back to idle. Now, obviously, the faster it gets back to idle, the more power you save. Now, what we're looking at today is just shortening this time by reducing the execution time so that it can go back to an idle mode or to a deeper sleep mode more quickly, and thus reduce the whole power consumption. Now, the idle level by itself, of course, is determined by the technology that we're using. So, going into the future, what we can do is what we do already, reduce the execution time, but also try to lower the let's say, the base power consumption of the processor. And we will also look into tools, as James already mentioned, that help you reduce the power consumption during execution by, let's say, very smart distribution of your application in memory, trying to minimize memory access or whatever. So there's different ways to address this performance power optimization, which is specifically a very hot topic for all the handheld devices and mobile devices. Now, a couple of items that we are targeting for the, let's say, on the application development side right now. As I mentioned before, what matters most to customers right now is the ease of use, so we are constantly working on simplifying the workflow to develop an application, have a better integration into Q Creator. So right now, for example, the analysis, performance analysis, it comes up in its own window, so we want to work on this, making it more of an integrated experience. Eventually come up with a competitive user experience as for iOS and Android SDK. I mean, this is what we're up against. And additionally, is that power analysis tools, and also help with tools that help importing an application from one operating system to another. And there's tons of applications out there that if we want Migo to be successful, we need a big application developer community, and if we can facilitate porting of applications and make it attractive for customers to simply port their application to Migo, we can get a lot more traction there. On the embedded side, as I mentioned before, systems were getting more and more integrated towards system on chips. So we're working on extending the debugging not only on the immediate processor, but also to the whole system. So there's a lot of things happening outside the processor that you will want to debug. So we'll extend our offering there. And also we're looking into what operating systems are most important for us to support in this very fragmented embedded space. Now the question is, I never talk about multi-core and multi-threaded. Everything is usually the big topic that Intel is talking about. Why not in the embedded space? Well, it's not, I wouldn't say it's not there, but it's used in a specific way. The embedded customers right now, when you think about multi-core, think more in terms of what I call here, well, it's driven by consolidation in a sense. Right now, in the embedded world, you have very often multiple specialized CPUs that are designed for specific tasks with a specific operating system. Now the idea is more to consolidate those into multi-core processors and give each core a dedicated task and a dedicated group of applications. This is what I mean by consolidation separation. So you consolidate applications that, let's say, run in a similar security context and map them, assign them to a specific processor through a specific OS. And you group another piece of applications and let them run on the same processor but on a different core, either with their own dedicated OS, or you insert this kind of a hypervisor layer in between that handles all this and extracts the actual core from the application. So it's a different way of, we're not talking so much about, at this point, about classical multi-threading as we do on the big cores. That's what matters right now in the embedded area. In the future, of course, as we see, as multi-threading becomes more pervasive in the embedded space, like from smartphones, and we see more multi-core CPUs also in on Atom. This will become a topic like for the classic tools as well, of course. And it's no wonder that we will have all the features that we have now in the Parallel Studio XD, for example. They will all filter over as required, as we see a need for it, into the embedded tools. So nothing surprising here. Of course, we will continue to look at the extras that are required for the embedded developers here. And as I said, we're looking into relevant target operating systems, what we need to support there. So, and the goal, of course, is that we provide the best-in-class support for IA in all these areas. Now, in summary, I want to give you 2 slides that summarize pretty much what I said before and how we see the different roles there again. Now, obviously, we are as a silicon provider. Well, that's just a very simplified way of how a device gets created. So you have silicon provider and operating system provider. Those two together, I mean, these are the main ingredients that an OEM needs to take to create its device. And then he also has some what we call key ISVs that develop some, key applications that will be delivered together with the device. Like if you have a smartphone, when you buy it, there's always applications installed already, and these are provided by those key ISVs together in close cooperation with the with the OEM. And then once the device is out there, like for MeeGo, for example, you want to have a lot of other ISVs write applications for this device. Now, where's the tools in here? Now, what we're doing with Wind River is we're working with the operating system vendor, enabling them to provide the best architecture support in their tools, and they will deal with the distribution to the OEMs. Now, where's the resellers? We have a couple of resellers here, and you may wonder what's in it for you here. There is another path here that, of course, also for system development, it depends on the operating system. We're not going to go to, we'll probably not make it to go to Microsoft and say, can we enable you there, and you distribute our tools or some ingredients to your OEMs. This is not going to work. So it's depending on the operating system, on the setup. Sometimes this path, as through the regular software resellers for system development tools to the OEMs, will work. And since the OEMs also influence the key ISVs for application development, of course, you can also sell tools to the ISVs there. On the platforms now, and specifically for MeeGo, we are doing the platform enabling by giving the tools away for free, because in this area there's no way to make money. I mean, we have to give them away for free to make the platform a success. But there is a possibility in the end, if they are happy with the tools there, and they may also be working on other projects, of course there's an upsell opportunity for them to, for you as resellers to sell also tools to those developers if they do some other development outside of MeeGo. Now, talk through a lot of products here, and in the end I want to give you a product selector. The question, or the primary question, is what type of development. Now, if a customer comes up to you and says, what tools should I use? I'm an independent developer. Then it may become, you may think, oh, well, now, what's the right thing for this guy? Now, what I would suggest is you first talk about, are you doing application or system development? This is pretty easy. Not everybody wants to deal with hardware, it's bringing up a piece of hardware. Many people are writing applications for existing platforms. These are application developers. Now, what target OS do you use? If they're using MeeGo, here you go. We have the MeeGo application SDK. For QNX, we have the QNX compiler. For VxWorks, we have the compiler as part of the VxWorks platform. And guess what? For Windows and Linux, we have Parallel Studio XE. Now, that's a pretty simple environment here for application developers. Now what about system developers? Obviously, there is platforms where you develop for Windows and Linux, and they're even embedded, and you have system developers. So here you just need to add a third-party JTAG debugger, like from Control Lauterbach or what other American Arium, these JTAG probes, and you can use parts of this Parallel Studio XE also for embedded development, for system development. Similarly here, if you add the JTAG debugger, the JTAG probe here, you have a system development environment for WindRiver, and of course for our embedded system, our embedded development tool suite for, let's say, the OS agnostic or also for the Linux market without a specific attachment to an OS. For that one, you can use our embedded tools. So this is just a summary of where those products are placed. So in summary, I want to just wrap up what I mentioned before. So embedded development does require some specific tools or features, and we have most of them already in our products with specific features that help specifically for those embedded developers, and we are also committed to developing more of them, working with OS vendors to expand into relevant operating systems. And if you want more information, you can look them up here, and as James also mentioned before, my colleague Wille is available for questions you may have in that context as well.
Yeah, Intel's been talking about Android on Oak Trail. Any plans to cover, for example, the Android NDK with your tools for embedded?
No, for now we're not planning to cover that one with the tools, as that's a different. We don't have. It's mostly Java.
Yeah, the NDK though is native development on Android.
Right.
So
okay, for the native development. There's no plans for that right now. Any more questions?